Hi everyone, welcome back to the channel, and if you are new to this channel, kindly hit the subscription button down there. In this video we are going to learn about combined gas law. The combined gas law deals with the variation in the volume of a fixed mass of a gas with respect to changes in temperature and pressure. So from the statement, we can realize that the combined gas law, this is a combination of two gases, and that is Charles' law and Boyle's law. Charles' law and Boyle's law. Now, what is the mathematical expression of Charles' law? What is the mathematical expression of Charles' law? So now in Charles' law, we know that the volume is directly proportional to its absolute temperature. The volume is directly proportional to its absolute temperature. Now, that is the mathematical expression of Charles' law. And mathematical expression of Boyle's law is that volume of a fixed mass of a gas is inversely proportional to its pressure. Now, if we combine the two laws, that is this expression and this expression, we get volume is directly proportional to the temperature and inversely proportional to the pressure. Therefore, pressure and volume are directly proportional to the temperature. Hence having this expression, which is P over T equals to constant. If a fixed mass of a gas of volume 1 exerts a pressure P1 and an absolute temperature T1, then the expression may be written as P1 V1 over T1 equals to constant. Suppose the mass of a gas has a volume V2 and exerts a pressure P2 at absolute temperature T2, then the expression becomes P1 V1 over T1 equals to P2 V2 over T2. Now, this is the general formula or general equation of a combined gas law. This is a general formula of a combined gas law. So this is a very important equation. It enables the volume of a gas to be obtained under any conditions of temperature and pressure, provided its volume under the same other conditions of temperature and pressure is known. And this equation is called an ideal gas equation. Now let us see if you can use the same equation in solving some numerical problems. Here is a question. So let us see if you can use the ideal gas equation to solve this problem. So the question is asking us to find the volume. So here is the question. A given mass of a gas occupies 20 cubic centimeters at 25 degrees Celsius and 670 millimeters of mercury pressure. Find out the volume it will occupy at 10 degrees Celsius and 335 millimeters of mercury. Let us recall the ideal gas equation. So the ideal gas equation is P1 over T1 equals to P2 V2 over T2. So in the question, our V1 is 20 cubic centimeters. P1 is 670 millimeters of mercury. T1 is 25 degrees Celsius. Remember, V stands for volume, P pressure, and T temperature. Now, What is our V2? V2 we don't have, because that is what we've been asked to calculate. P2 is 335 millimeters of mercury, and then temperature 2, which is T2, is 10 degrees Celsius. Now let us equate these values into this formula. So P1, which is 670 millimeters of mercury, multiplied by V1, which is 20 cubic centimeters, divided by T1. And in this case, we must convert temperature to an absolute temperature, that is degrees Celsius to Kelvin. So if we convert 25 degrees Celsius into Kelvin, what shall we get? So there is another video that I posted on how to convert degrees Celsius into Kelvin. So if you've never watched that, kindly you can go back to the video and take a look. So if you have 25 degrees Celsius, you add 273. So that will give us 298 Kelvin, equals to now pressure 2, which is 335 millimeters of mercury, multiplied by volume 2, which we don't have, out of temperature 2, which is 10 degrees Celsius, and we need to convert. We must convert 10 degrees into Kelvin. So if you do that, we'll get 283 Kelvin. Okay, now we have our values. And now how can we calculate the value of V2? How can we calculate the value of V2? Now, there is a simplest way of how to calculate the value of V2. And here is the simplest way. So first, you can start by multiplying both sides by 283 Kelvin. And then you multiply the other side by the same value, that is 283 Kelvin. So the 2 will cancel and will remain with 283 Kelvin multiplied by 670 millimeters of mercury multiplied by 20 cubic centimeters all over 298 Kelvin, equals to 335 millimeters of mercury multiplied by volume 2. Then after that, we divide this side by 335 millimeters of mercury, and the whole of this by 335 millimeters of mercury, which will be this way, 335 millimeters of mercury. Hence, V2 will be 283 Kelvin multiplied by 670 millimeters of mercury multiplied by 20 cubic centimeter all over 298 Kelvin multiplied by 335 millimeters of mercury. So the units will cancel. And what will remain, we key that into our calculators. So if we key in 283 multiplied by 670 multiplied by 20 cubic centimeters, divide by 298 multiplied by 335, what shall we get? So if we key in 283 multiplied by 670 multiplied by 20, we'll get 3,792,200 all over. Now we'll also key in 298 multiplied by 335. So what shall we get? We'll get 99,830. So from there, you just take 3,792,200 792 and 200, you divide by 99,830. So what will you get if you do that? You get, now if you key in these values in your calculator, what will you get? So V2 will now be 37.98 cubic centimeters. So that is our volume. That is our volume, 37.98 cubic centimeters. Up to that point, it's my hope that it is well understood. And in case of any question, you can just ask in the comment section. And don't forget to like the video, subscribe, and share it to your colleagues so that they benefit. Until next time, have a wonderful time.